Part of your advanced version for this skill is going to be graphing linear inequalities. And basically it follows the same kind of rules as graphing a regular equation at first. So let's look at this very first question. We're going to graph it first just like y equals negative 2x plus 5. And as a reminder, here's our slope, which is rise over run, and here is our y-intercept. So y-intercept of 5 means that it intercepts the y-axis at 5. Makes sense. And then when the slope is negative 2, that means we're going to go down 2, the rise is 2, and then over 1. So down 2, over 1. Down 2, over 1. Down 2. Okay, so really you only need 2 points to get a line, but I want to make sure my line's good. Now, when we're graphing this inequality, if you've got greater than or equal to, it's a solid line. When we come over to this next problem, if it's just greater than or less than, then it's going to be a dotted line. Okay, but in this case, it's solid, so I'm going to use my line tool. And I'm going to go ahead and I'm going to connect these. Okay, put arrows on the ends to indicate that it goes on forever. Alright, and now I want to look at what part of this is our solution. So we know that everything on the line is the solution, but since it's not just equal to, it's greater than or equal to, we need to test some values. So let's go ahead and test 3, 1. We want to see if this is included in the solution. So 3, 1. In order to see if this is included in the solution, we need to plug those back into the original. So y is 1. Okay, negative 2 times 3 plus 5. All right, 1 is greater than or equal to negative 6 plus 5. 1 is greater than or equal to negative 1. And then you see if that statement is true. If it is true, which in this case it is, this is the side that we want to shade. Okay, so alright, if it was not true, we'd go and we'd try some point that's not on this side, so we'd probably try 0, 0, for example. If we tried 0, 0, you'd see that, well, 0 is greater than or equal to negative 2 times 0 plus 5. 0 is greater than or equal to 5 is not true. So that means that we wouldn't shade on this side because this is not a solution. Okay. Now let's come over to a slightly more difficult problem on the right. What makes it more difficult is it's not in an easy to graph form yet. So we need to put it in this y equals mx plus b form. That's our first step. So let's go ahead and do that. And this just requires some manipulation. So we want to get y by itself, so we're going to subtract 9x from both sides. Alright, so then we've got 2y is less than negative 9x plus 10. Okay, and then divide by 2. So y is less than negative 9 over 2 times x, and then 10 divided by 2 is 5. Okay, so when we graph this, now we're going to go ahead and we're going to use this y-intercept here of 5. It's a coincidence that they're both 5. And then a slope of negative 9 over 2 is down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then right 2. 1, 2. Okay. Now, when I graph this line, it's going to be dotted because we have a sign that's not or equal to. It's just greater than. So that what that means when we do this dotted line, sorry, my line kind of, it sucks. When I do this dotted line, what that means is anything on the line there is not in the solution. Okay, so it's not part of our solution. When we go ahead and test a point, usually the easiest point to test if it's not on the line is 0, 0. So let's go ahead and test that. And you can test it in the original or you can test it in your new one. So I'm going to test it in this new one. 0 in for y is less than negative 9/2 times 0 plus 5. You get 5 is bigger than 0. That is true. So we're going to shade the part of the graph that has that point underneath the graph here. And that's the basis for this skill. So big things to remember is it's easier to graph if it's in y equals mx plus b form. If it's a less than or equal to or greater than or equal to sign, that's a solid line when you graph it. And if it's just less than or if it's just greater than, it's a dotted line because we're not including those solutions. And when you want to choose which side to shade, you need to test a point, and if that point turns out to be true, like it did in this case, then you shade that side, and if it's not true, then you shade the other side. And that's just about it.